All right, good morning, kids. Here's section 4.3, number 44. To give you a function, they also have a lingering point off to the side. We're going to talk about what that means. Directions for part A say find an equation of the tangent line to the graph of this function at the given point. What they are telling you, this is kind of nice, is that I'm not exactly sure what this function looks like. I'll just kind of make one up. They are telling you that it definitely contains the point -2, 2. Now, I know for a fact that this is not an accurate drawing, so you ought to be able to tell that if you multiply this, you'd get a degree 3, and I did not draw a degree 3, so I'm just talking generically here. If you have some function, what you can do to test it out in this instance, +3, something squared -2. So what I've done is taken my function, gotten it ready to substitute. Sometimes they just say, find the tangent line for the given x value. And you would have to do this. You would have to substitute a -2 into all these places, do a little math. This means that when you put -2 into this function, this is 1. This is 4 minus 2 is 2, and you have a product of 2. All that means is that when you put -2 into your function, you get 2. Well, again, like I said, they gave that to you. That was a gift. So now what? We're still kind of not sure what to do. What you can do is, don't forget, this has been a while, figure out the derivative. When you put that same x value back in, you will get a slope. That's the slope of this line. In this case, it kind of looks like 1, let's say. Again, this is not an accurate drawing. Now that you have a given slope and a given point, you can use point slope technique or slope intercept technique. That's probably our favorite. So now you're going to sit and watch me erase. Here we go. So, number 1, we're still going to figure out the derivative as by using the product rule. It doesn't say find the derivative. You need to know that you do that. The derivative of the first part is 1 times the second part. The first part times the derivative of the second part. Now, since the given point was -2, 2, we're going to take the x value, that's all we can do, and substitute it into our derivative function. That's what I'm doing here. Well, let's hope we do this right. And I'm going to show you how to check your work. That's basically what they want you to do in parts B and C. So substituting -2 in the derivative gives me, this one is kind of redundant. Here you have 4 minus 2 is 2. This product is 1 times -4 is -4. I got a value of -2. That is the slope at that point. We hope. Oh, that was a terrible. So for part B, we are going to take two things. We're going to take our point and our slope. You know what? We're not done with part A. Part A says find the equation of the tangent line. We're not done. So for part A, we're going to take our point, -2, 2, and our slope of -2. I honestly prefer point slope. We'll do slope intercept. Y equals mx plus b. I'm going to substitute this 2 in for y, this slope in for m, this x value in for x. Do a little math. And get -2 equals your y-intercept. So the actual answer to part A is y equals -2 for slope and -2 for y-intercept. That is the equation of the tangent line. I can confirm that by checking my graph. First of all, I want you to notice that this is the original function. It does clearly look like it contains the point -2, +2. If I were to draw a tangent line right through there, it would seem reasonable that, first of all, the slope is negative, and also that the y-intercept is -2, and et cetera, et cetera, et cetera. So now I'm going to just confirm that y equals -2x minus 2 seems reasonable for a tangent line. So, in fact, that is the equation of the tangent line. Now, part B, let's see if I can... Let's see if I can discuss part B here. Use graphing utility to graph the function and its tangent line at the point. So basically, do a little drawing that looks like such. Doesn't have to be super great. There's the point, -2. There's the tangent line. Oops. There's the tangent line. Part C. Wouldn't you guys like to know how to do part C? Part C says, use the derivative feature on your graphing utility to confirm your results. There is such a thing. Desmos has it. I didn't want to show you. Fear that you might use this too often. You can type in f prime of specific point. So I'm going to shove in there -2, and you'll notice very lightly it says here that you have -2. All that means is that when you evaluate the derivative of the original function and put -2 in, you get -2. That was the slope of that blue line there. So good luck with this. Let's